Hi, and welcome to our fourth lesson of Unit 10. Today we are going to be learning about a math concept that you probably hear every single day in your life, just in common language. And it's really exciting that today we're going to discover that topic and see where it comes from. To do that, we are going to start by engaging in our think about it. So in a second, I'm going to ask you to pause this video and go over to Desmos, and you're going to answer two questions, part A and part B. Before you do, we're going to read through the problem together so you understand what you're working on. It says a group of 6 students made the table to the right, even though it's underneath, about the number of people in their households. They wanted to figure out the typical number of people in a household using the data. And there you can see the data that's given. One student, Robert, said that the median is 3.5. So the typical number of people in a house is between 3 and 4. That's what we learned yesterday. Another student, Michelle, had a different idea to figure out what was typical. She first represented the number of people in each household using cubes, which you can see there below. For example, we see that Ozzy in the table has 2 people in his household, therefore there are 2 cubes above Ozzy's name. She then redistributed the cubes so that each household had the same number of cubes in its stack of cubes. You're answering 2 questions. The first is, using Michelle's method, how many cubes are in each of the 6 stacks after she redistributes the cubes? Then you're trying to determine if what she did is representative of the data set. You'll have 2 minutes to go into Desmos to answer part A and part B of your Think About It. Your teacher's then going to call on a few scholars to share before we come back together. Go ahead. Let's look at what I did to solve this problem. We know this given information that started at the problem, that was the data that Michelle collected. We also know that there are 24 total people in all of the households, each represented by a cube. I got that, 1, by counting all the cubes, and then 2, by counting all of the number of people that I see in that table. I can then represent those 24 people. I didn't make cubes, but you can see these as squares. So there's 24 squares there, 1 for each person. And then Michelle said that she redistributed those 24 back to the 6 people evenly. So each of the 6 people has 4 people in their household now. That number 4 is the mean, or the average of our data set. Now, this is a new term and we haven't dug into it completely, but based on what you know about data and looking at this data and this method here, do you think the mean of 4 is representative of this data set? When I say go, you'll pause the video and vote yes or no, then your teacher will call on 1 or 2 scholars to share. Ready? Go. The mean of 4 is representative of this data set because, as we saw in this table, our data ranges from 2 to 6, and to say that on average there are 4 people in a household is reasonable given the numbers that we see here. So we just found the mean by redistributing these squares or these cubes. But there's a more streamlined mathematical way to find the mean. So my next question for you is, how do we calculate the mean? You have your data set there and you have the thought process that Michelle and we just went through. How do you calculate the mean without having to draw 24 cubes every time? When I say go, you'll pause the video, go back into Desmos, and try to come up with a generalized way to calculate the mean. I'll put up the previous screen so that you have it so that you can use it as you're answering. Ready? Go. Remember, the first step we took was identifying that there were 24 cubes. We got that by adding all of our data points together. So step 1 in finding the mean is adding all of our data points together like you see here. Then we redistributed those 24 cubes to each of the 6 people. We got 6 by looking at the number of data points. There were 6 people surveyed, so there were 6 data points. That's step 2 in finding the mean. We divide by the number of data points. Again, I got 6 because there were 6 data points in this set. 24 divided by 6, I know is 4, and 4 is my mean. That's how we'll calculate the mean anytime we are trying to find the mean. And as we know, mean and average are the same. That brings us to our key point for today. Data can be added and divided by the number of data points to find the mean. Before we dive into a more complex example, we're going to do a quick check for understanding to make sure we have the process down. So when I say go, you'll pause the video and you'll see a screen like this in Desmos. You're answering this quick CFU so your teacher can review your responses before we're ready to move on to a more complex problem. Ready? Go. If you wrote divide by 4, you were exactly right. There were 4 numbers in our data set. Therefore, the second step in finding the mean was to divide by 4. Let's move on. This question says, Michelle asked her classmates for the number of hours that they usually sleep when there is no school the next day. I know I certainly sleep more hours when I know there's no school the next day. Their responses are recorded below. And we see that dot plot. Use the dot plot to determine the average number of hours of sleep that her classmates get on a weeknight. What does this value represent? The first thing I know is that when I see the word average, that means that I'm finding the mean. So I know that I need to take 2 steps in finding the mean. Step 1, add all of my data points together. And step 2, divide by the number of data points. Before you dive into solving, I want to give you 2 options for step 1. Approach number 1 would be to add 7 plus 8 plus 9 plus 10 plus 11, and then you see approach 2 below. Do you agree that we should follow approach 1 or approach 2 as our first step in finding the mean? When I say vote, you'll hold up a 1 or a 2 so your teacher can see your response and then call on one scholar before we come back together. Ready? Vote. Approach 2 is correct here. We know that we need to account for every single data point. So adding 8 just once would not suffice because there are 4 data points above 8. I also could have written approach 2 like this and wrote out every single data point. Given that as our first step, now it's your turn. When I say go, you'll pause the video and find the mean of this data set. Then we'll come back together to debrief. Ready? Go. Take a look at my work here. Notice how when I added all my values together, I got 90, and then lastly, I divided by 10. I got 10 because there were 10 dots on my dot plot. There were 10 data points in this data set. Therefore, I got the mean to be 9. Go ahead and give yourself a virtual clapping hands if you got a mean of 9 when you solved this problem. Now that we have our mean, we need to be able to interpret it. What does 9 represent in the context of this problem? When I say go, you'll pause the video and go into Desmos and answer this question so your teacher can see if you understand not only how to calculate the mean, but how to interpret it. Ready? Go. The mean of 9 in this problem means, on average, Michelle's classmates slept for 9 hours when there is no school the next day. That is a number that is representative of this data set. Again, we used our key point to find the mean by adding all of the data and dividing by the number of data points. That's how we find our mean every time. And before you jump into work, please review the CFS you see here. First, annotate to determine what you are finding. You might see average, you might see mean, so make sure that you interpret that. Second, add together all the values in the data set. Third, divide by the number of values. Fourth, interpret the mean like we just did. And lastly, check for reasonableness. Is this within the range of the data set? And does this represent the data? If you forget a step, you should be able to catch your mistake by checking for reasonableness. Good luck with your practice problems today, and I will see you for our next lesson. Have a great afternoon.